Hello. In this video, we want to find all relative extrema for the following function, as well as where the function is increasing and decreasing. So we have f of x equals 6x to the 2/3 power minus 4x. So the first thing we want to do is find any critical points, which means find the derivative. So the derivative here, bring the 2/3 down in front, times 6, will give you 4, and then x to the 2/3 minus 1 is negative 1/3. And then minus 4x becomes just minus 4. Good. Now notice that this is actually the same thing as 4 divided by x to the 1/3 power minus 4. And technically 4 over 1, so I'm going to multiply this by x to the 1/3 power in both numerator and denominator, making that 4 minus 4x to the 1/3 power all over x to the 1/3 power. So this would be the derivative. Now the reason that I did this is because I want to know what are the critical numbers, because the entire function would equal 0 or would be undefined. So in order for it to be equal to 0, the numerator would equal 0 or the denominator would equal 0. The numerator would be 4 minus 4x to the 1/3 power, and the denominator would be x to the 1/3 power. So here, subtract 4, so negative 4x to the 1/3 equals negative 4. Divide by negative 4, so x to the 1/3 power equals 1. Cube both sides means x equals 1. So x equals 1 is a critical number. Then for the other one, x to the 1/3 power, cube both sides, we have x equals 0, and that's also a critical number. Now notice that this 0 and the 1 are both within the domain here. It's just that at 0, the derivative itself is undefined. Alrighty, so let's go ahead and use a number line. So on the number line, we have 0 and we have 1. And we need test points. Between, or to the left of 0, we need it to be, let's say, negative 1. Between 0 and 1, let's say a half. And greater than 1, let's say 2. And those are the x values. And we're going to plug those into the first derivative. Now, at negative 1, you're going to get negative 8. In other words, f prime of negative 1 equals negative 8. So it's going to be negative in that region. In other words, the function is going down from left to right. And whenever you plug in a half, let's find out what a half would be. That's going to give me approximately on the derivative, because this is not an exact value. A half would give me 1.0397. But the point is that it's positive. In other words, it's going up from left to right. Now at 2, f prime of 2 is going to give me negative 0.825. Which of course is negative, which means it's going down from left to right. Wonderful. Now, let's go ahead and talk about where this function is increasing and decreasing. So this function is increasing on the interval from 0 to 1, and it is decreasing on the intervals from negative infinity to 0, comma, and then 1 to infinity. Good. And let's talk about relative maxima and minima. Notice that we have a sign change here, which means 0 is in fact a low point, and the 1, it goes up and then down, that's also a high point, so that's going to be a relative maximum. Now, where these occur, so f of 0 is 0. And f of 1 itself, notice I'm plugging these into the original function itself. F of 1 is 2. Good. So there is a relative maximum of, now notice that the maximum occurs at the 1 here, so there's a relative maximum of 2 at x equals 1. And there will be a relative minimum of 0 at x equals 0. Good deal. All right, now that you have seen the calculus, I do want to show you what this looks like on the calculator, so I'm going to go ahead and see you there. And yeah, I'll see you there. Okay, so welcome to the calculator. Notice that on y1 here, I've typed in the original function, and on y2, I typed in the derivative. Now, this isn't the final derivative, it was just the one that we got when we first took the derivative. So it's perfectly fine to use this, at least when you're, typing it into the calculator. Now, let's go ahead and graph this on the standard window. Here's what it looks like. So the blue is the function itself, and the derivative is the red. Now, notice that critical values will occur when the red is equal to 0 or has a vertical asymptote where it's undefined, like what's happening here. So it's at 0 and at 1. Or you can see it from the blue. Notice that there's a sharp edge here, so that makes that a critical number. And the other critical number happens here where it changes. Now, this won't find all critical numbers if you're not careful, because sometimes critical numbers aren't actual maxima or minima. As for the table, let me go to table set here, and let me change this to auto. And then on the table, here's what you would normally see if you are going by ones on the x-axis. So I looked on here and I saw f of -1. Well, here's -1. The red is the derivative, so f of -1 is -8. And then f of 2 was -0.825. But notice I don't have a half here. So how do I get that? Well, you can just go to second table set, and don't worry about any of that. Just go to ask for the independent. And notice what changes here. There's nothing here. That's why you have to type it in, 0.5. And notice that the y2 is 1.0397. But it's positive. That was the point. And as for the other values, I can type in 0 and 1. And the blue is the function values itself. So at 0, it gave us 0. At 1, it gave us 2. Notice that the derivative at 0 is an error, because that's just where the derivative is undefined. And at 1, it gave us 0. And that's good, because these are, in fact, critical numbers. The first derivative should be either an error or 0. Good deal. Alrighty, and again, here is the function itself, and here is the derivative. Well, I think I'm going to go ahead and end the video here, and I will see you in the next one. Have fun.